right, here we go. So you guys are going to think it's funny. I just actually recorded this once already, but I forgot to hit record. So, take two. Let's get all the way up to the top here. When I last left you, we were talking about, we got a default storage location set up. That's great. Now we're going to look at a couple of the different types of data, kind of the classifications of data that we'll be working with. And there, we have two big classifications of data. That's vector data and raster data. So those are our two main classifications of spatial data, vector data and raster data. And then within each of those, we have a few different types of files. Vector data are represented by points, lines, or polygons. So points, lines, or polygons. So you can see kind of what I mean by those, yeah? Come on, and select, there we go, point, line, or polygon. So vector data represent point, lines, or polygons. And our most common type of data when we're dealing with vector data are going to be feature classes. And so feature classes are just kind of what they sound like, a collection of features. So features might be things like, let's say, fire hydrants. So one fire hydrant is a feature. Let's say we had 100 fire hydrants, and we recorded their location of the location of each fire hydrant, and maybe we also recorded, let's see here, the location, and then maybe the color, and maybe the gallons per minute, and maybe the last time they were tested. And collectively, we'd group those all together in a feature class. So it'd be a collection of features. The feature in this case is a fire hydrant. You could also have a collection of streets, maybe 1,000 streets in Spokane, and you could have information on each, like maybe what it was paved with and how wide it was. So that would be a feature class. Each feature would be, one feature would be one road, but together they make a feature class. So feature classes are placed on a map. When you pull them into the map, they become a layer on the map, and they have to be stored in a geodatabase. We'll take a bigger look at geodatabases a little bit later in this talk. Examples include feature class of roads, and that would be line geometry. A feature class of culverts could be point geometry. A feature class of parks could be polygon geometry. Let's take a look at what those actually look like. So we are actually going to recreate this map soon, not quite yet, but soon. And what I wanted to point out here is over here in the catalog, we have our geodatabases. We've got 1, 2, 3 geodatabases that this project is connected to, all right? And inside the Parks and Boundaries geodatabase, we have 1, 2, 3, 4 feature classes. So we have a feature class called State Parks, one called Spokane County, one called County Parks, and one called City Parks. And so those are our feature classes in the Parks and Boundaries geodatabase. In the Water Infrastructure geodatabase, we have a culverts, rivers, and stormwater structures. And what I wanted to point out here, I'm going to zoom in a little bit, is that each of these parks are feature classes are polygons, and you can tell because this symbol is supposed to kind of look like 3 polygons. Similarly, the culverts are points, and you can tell because the symbol is supposed to look like 3 points. And then the rivers is a line feature class because it's supposed to look like lines right there. So I just wanted to point that out. Feature classes are stored inside geodatabases. In our catalog, they look like silver cans. See that? And the feature classes look silver too. So that's kind of a way you can tell something's a feature class. And then over here, you can see them on the in the table of contents. This means that they've been added to the map. And so we've got culverts. Those are the light blue points on the map. We've got rivers. Those are the dark blue lines. We've got county parks. Those have a dark green outline. City parks have kind of a lighter green outline. And then I turned off the state parks. You can tell they're turned off because they don't have a check mark next to them. And it's all on top of a light gray base map. So you can see some neighborhoods like Colbert and Meade here. So this is the Parks and Boundaries geodatabase. We know it's a geodatabase because it's a silver can. It also has the file modifier suffix .gdb, and it's got city parks, county parks, Spokane County, and state parks. So if we look at that in the catalog, that's what it's going to look like, and we're going to manage it there, and we could move things around, we could drag them onto the map, that sort of thing. If I look here in my, if I were to look in Windows File Explorer, what do you mean by Windows File Explorer? Well, in Windows 11, I'd click here. This is File Explorer. If I were to open up my geodatabase here, this is what I'd see. It looks like gobbledygook, doesn't it? Yeah. So I don't see anything that says like state parks on here or city parks. It's just a bunch of letters and numbers and codey things. And usually, at least a few times a quarter, I'll have a student come to me in panic, and they'll think, hey, my data's been corrupted, or this download didn't work because, look, I just have gobbledygook when I open the geodatabase. But that's just because you opened it in Windows File Explorer. If you go over here and you open it in the catalog, it's going to look smooth, and you'll be good. There'll be no problem. All right. So I just wanted to kind of throw that out there. So when we manage our files, and what I mean by manage is rename, cut, copy, paste, move, make new geodatabases, make new folders. That all is going to happen in the catalog, okay? Because that's going to be the most efficient way to deal with these data. If you were to open them in Windows File Explorer and try to do some moving around, you know what would happen? You'd invariably lose some of these files. You wouldn't move something, you'd delete something, and you'd render the data inoperable. So don't manage your files in Windows File Explorer. Get into the catalog. Moral of the story. All right, what else did I want to point out? We are going to, I think I said we are going to recreate this shortly. Actually, it's going to be our next video demonstration. We're going to recreate this map ourselves. It's going to be super fun, so stay tuned. Let's learn a little bit more about another type of vector data. These are shape files, and this is kind of, this was the standard a decade or two ago. So shape files are also vector files, and they're a collection of similar spatial features that have the same geometry. So what I mean by that is points, lines, polygons, and they have to be stored in a folder. So these don't go in geodatabases, they won't fit, they don't work. It's an outdated file format. In general, it's going to be larger than a feature class, it's going to load slower, and it's not able to be used for input in most geoprocessing tools. So you're definitely going to run into shape files, but they're not going to be as useful for most of the things we do. And so we can use tools to convert them into feature classes and save them in geodatabases. But you will run into them for sure. The agencies are going to give you shape files. You'll have them to deal with sometimes. So this is what a shape file looks like in the catalog. And you can tell these are actually polygons. They have a similar polygon nature, but look, they're stored in a folder, not in a can, a geodatabase can, and they're going to be green rather than silver. So that's going to be our shape files. If we were going to take a look at them in Windows Explorer, which you shouldn't do, they're going to look messy. You're going to have multiple, it's usually 4 to 7 files for each shape file. And so that's not something we're going to work with. Just a second here. All right. So, shape files versus feature classes. Shape files are outdated, but you can convert them to feature classes. All right. That just kind of boils it down. So ArcGIS Pro can actually read in other vector file types too. Yay, useful, because we're going to be collecting data in the field or generating it using other things sometimes. So you will need to use geoprocessing tools to bring the following file types in. So this is going to be, GPX is going to be like a GPS track or GPS data. And you can use, so if you've got like a Garmin, or something like that. And what you're going to use, let's see, it's called, I think GPX to feature, but let's look up that tool. So if we want to see a tool, we can go to Tools, and it's actually, it'll open this pane for us, and we're going to type in GPX to find the tool that will convert GPX files. It's going to be GPX to features. And basically that'll take data that you collect on your Garmin or other GPS, and it'll bring it into Pro. KML or KMZ files are from Google, and KMZ file has elevations for it, so it can be used like in elevation type stuff. And you're going to use, to bring these in, you're going to use KML to layer, that tool. And so you can absolutely collect data in Google and then bring it into GIS Pro. One of the most useful ways to do this, I found, is that Google allows you to search for like commercial businesses. So for example, I could do a search and get all of the McDonald's in Spokane, and then I could download that layer as a KML and pull it into GIS. That type of like commercial business data isn't generally readily available in other ways, and so sometimes it's useful to pull it off of Google and to bring it into Pro, and then we can do fun GIS stuff with it. So there's that. So these are our vector data. Okay, so points, lines, and polygons, and some different file formats. We've got feature classes, shape files, GPX, KML. But what about the other main type of data? That's known as raster data. And apparently I didn't delete all this when I accidentally didn't record the location, or record this demonstration. So here we go. Raster files are going to represent continuous or categorical data, really best used to represent continuous data. So basically what happens is a grid is draped over the surface of the Earth, and one value is assigned for each cell in the grid. And when we talk about resolution, I said also known as resolution here, aka resolution, that just means when someone says, oh, this raster has blah, blah, blah resolution, it's got 30 meter resolution, it's got 1 meter resolution, it's got, half a meter resolution. What they mean by resolution is just the size of that grid. So if you think about graph paper, think about the size of the squares and the size of the squares on the surface of the Earth. A 30 meter raster has a grid that's 30 meters square, so 30 meters on each side. And then each of those cells is given a value to represent the value on the ground. So for example, if we were working with elevation and a 30 meter raster, it'd be like we draped a grid across the surface of the Earth, and each of the squares of the grid was 30 meters. And then what we would do is we'd give you the average elevation within that 30 meter square, and that's what would be recorded as the elevation. You could do that with wind speed. You could do that with temperature. Let's say we had a 10 meter raster over Spokane with temperature, and basically it'd be squares that were 10 meter by 10 meter, and we would record the temperature in each of those squares, and that's what we would report. So there's kind of a nice graphic over here to the right in your workbook. It shows what data looks like as either a vector or a raster, and what you can see is some data is just better represented as a vector. So when we're just looking at little points, it kind of makes sense to just put points where those are, like they're fire hydrants, rather than a grid that says red for yes fire hydrants, blue for no. But for some modeling, rasters can be useful as well. So I'm not going to say that they're never useful, but in general, raster data seems to be most useful for aerial imagery of any sort. It could be heat sensing, it could be color sensing, it could be infrared, well, which is heat sensing. Aerial imagery, it's good for elevation, it's good for wind speed, it's good for temperature, those kind of things. So raster data can be useful for continuous. And what by continuous data, I mean data where every spot on the Earth's surface you can capture a value. Could be good for things like CO2 concentration in the atmosphere. So right here where I'm sitting, I might have one CO2 concentration. If I were to snuggie up to a tree, I might have a little bit lower CO2 concentration, a little bit higher oxygen concentration. So things that are continuous on the surface of the Earth are good for modeling with rasters. Convenient to model with raster. I have a data set for us that we'll have a chance to look at soon in our next video. I have a data set for us that's going to look at temperature in all of North America, and that's kind of a fun one. But that's a fun raster one. Vector data is great for features on the surface of the Earth. I would say just like I can use the word discrete. It means they're not continuous. So like it's not like one fire hydrant melds into another and then changes to the next. It's like either there's a fire hydrant there or there's not. Whereas temperature, it's like, oh, the temperature increases slightly, melds into another, and now it's higher over here. So discrete features on the surface of the Earth. So we're going to say, for example, e.g., sure, I just like to use the hydrants, right? Oh, what's going on here? Hydrants. Whoa, come on. Hydrant's. So, for example, hydrants, rivers, towns. So, points, lines, and polygons, discrete features. It's going to generally be better for vector data. All right, so moving right along. Folders. This is going to looks like a kind of yellow-orange rectangle in your catalog. And a folder can store shapefiles, yes. It can store like Excel and Word docs. It can store ArcGIS projects. It can store some rasters as well, just depending on the file type. It can store GPX files. It can also store KML files. So folders can store some spatial data, some types of spatial data, and a bunch of other stuff too. Geodatabases look like a silver can in your catalog, and they can store feature classes, Esri, rasters, and some Esri tables and that sort of thing. So geodatabases store kind of some specific types of spatial data. So this is kind of showing us the depiction of file types stored in a geodatabase, and this is what they look like in the geodatabase. They're going to look silver, feature classes. This is a table. Here's some polygon feature classes. All right. So that's where I'm going to end for this this segment, and then we're going to move on to kind of how to work in the catalog, and we're gonna do some of that. So that's coming up.